Hello and welcome back to the Inside Java podcast, a podcast about everything Java brought to you by the team at Oracle that builds Java. My name is Nicolai Parlog and I recorded this conversation with Brian Goetz after his talk at Java 1 2025 as part of a live stream to our YouTube channel. Brian is Java language architect at Oracle and, among other things, lead of OpenJDK projects Amber and Valhalla. Brian shared insights into how features are incrementally designed and delivered, Amber's next big feature arc, Valhalla's plans for null restriction and more. Enjoy the episode. But yeah, let's start with Amber. And you gave a talk about that and the other language evolutions yesterday. Maybe give us a little bit of an insight.
Yeah. So Project Amber is kind of unusual among the OpenJDK projects. So there's a lot of projects going on, Loom, Valhalla, Babylon, etc. And most of the other projects have a single focus, right? Loom is about virtual threads and structured concurrency, and Leiden is about startup and warm up, and Amber is like all over the map, right? And most projects deliver a small number of coordinated JEPs. Amber is like this JEP cannon that fires off JEPs every 6 to 12 months, sometimes multiple JEPs in the same, in the same release. And so it's kind of a different beast. And the tagline that we gave it when we started Project Amber was that it was about right-sizing language ceremony, which is to say the language features that are smaller than big things like generics and lambdas and what have you. And this sort of coincided with our switch from the doing releases every 3 years to doing releases every 6 months. And so it was kind of a forcing function to learn to take medium-sized features and break them down into a bunch of smaller features. Yep. And this works really well, and it allows us to deliver things faster, and it allows us to deliver things that are individually simpler so that people can sort of wrap their heads around it easily and see the value in it. But it's kind of a double-edged sword because it means that we don't ever get a big thing like generics or lambdas, and we probably never will again, not because we're not doing big things, it's that we're taking big things and we're slicing them up into a bunch of smaller things and delivering them over time. So, in the talk that I did yesterday...
So briefly,
go ahead,
on the double-edged sword, I was wondering, is it also a certain risk that you're cutting things and then you have to, because then you have to make decisions sooner, right? If you would make it all in big lump, you can say, okay, we're basically done on this feature, but we'll wait until we're done on all the features and then we see perfectly how they fit together. So has that been a problem or a concern? Or surely a concern.
It's an omnipresent concern and risk. We have done extremely well, avoiding that risk, in part because we don't just design the first little bit of it and ship it. Yeah. We may be designing 2, 3, 4 steps ahead, and then we say, okay, we see how all the pieces fit together, we see where we're going in the long term, and now let's identify a natural bit to sort of carve off, specify, deliver, and have it live on its own. And so, if you sort of follow the history of, for example, pattern matching, which has been a big theme in Project Amber, a lot of the original design documents that we wrote were 5-6 years ago at this point. Yeah. And
they're still informative. There's still stuff in there that we don't see yet in the language.
And those documents, address not only things that we delivered 3 years ago and 2 years ago and last year, but things that we're still yet to deliver. And so, just because we're delivering in smaller increments doesn't mean we're designing in smaller increments. Okay. And what it's taught us is, when you look at the releases from Java 8 and back, 8.7.6, et cetera, we had these big release drivers, these big problems to solve, and we've made unrealistic projections about when we would be done, and of course, the last part of it was always painful. But also, when we finished working on something like Lambda, we didn't really have a clear picture of what comes next. Because we had delivered everything we had been working on. And so there's not only like a pipeline stall when that happens, but also, since we haven't been thinking about how does what we work on today connect with what we're going to do tomorrow, there were often discontinuities between the efforts. Whereas now, we're co-designing a lot of pieces, So we're able to see what the interactions are, and there's much more of a continuity between the JEPs we do today and the JEPs we do tomorrow, even if they're not directly related on the same feature. And so that's something I think that we've been learning how to do, not only to carve things into smaller, more manageable chunks, but to sort of see what the connections are with other things that we may want to deliver in 2 years, 3 years, identify what the risk, the interaction risk is, and maybe not fully design the second piece, but address all of the aspects of it that might have interaction risk.
Well, that's interesting. So you're basically saying, I mean, yes, there's this risk that you misdesign something early, and then, but also that in another sense, that risk is less because instead of having like the big lambda thing, and when you're done, and you search for the next thing. Now that you have this continuous drive, you make it more likely that you're always thinking about the next thing. That you don't just develop lambdas and think only until that release, but you will always think about the features coming up after that. Okay, yeah. So then, but Amber does as you describe, but also there's some arcs, right? There's some things that are like larger stories within this. What you describe it as a canon of
a JEP canon. Yes.
JEP canon. Yes.
Yeah. So so some of the JEPs that have come out of Amber, like text blocks or local variable type inference, are truly standalone. We delivered them, they're done, we move on. But a lot of the things we deliver in Amber are part of a larger feature arc, like records and sealed types and pattern matching, which sort of all go together, or source launcher, compact source files, all of the on-ramp stuff, sort of that, the module imports, those all go together as well. And like I said, that's worked out really well because things like records are useful by themselves, and they also work great with pattern matching. And so we're able to deliver something useful now, and it interacts positively with something else later. But one of the challenges, there's always a drawback of everything, right? One of the challenges is it's hard. It's sometimes when we're explaining, well, here's what we're going to do in this JEP, and people want to, and they naturally want to judge it based on what's on the paper right in front of them. And not in the where are you going? And so that they'll say, oh, well, shouldn't it be this way? It's like, well, you might think it should be that way, but 7 JEPs from now we're going to want to do this, and this is part of a larger thing, and it makes it harder for people to see the big picture, right? Like when we did generics in Java 5, there was a big picture there, and there was a lot to absorb, but it all fit together. And now the big picture is like partially in the present, partially in the future. So that's a little bit of a challenge to manage. But I think overall, it's been a really good transition.
It makes also well, I mean, for us in DevRel, the 6-month release cadence, of course, is good because it means there's always something to talk about. But what you described there is also true. Like sometimes people look at the list of a specific release and it's like, wow, like JDK 24 is a good example. If you're like a language nerd like I am, you look at 24 and it's like, well, it's a couple of previews, nothing much there. So because all the big changes get cut up in small pieces, it's also easier to think, oh, nothing. I mean, there's constant movement, but there's not much happening. There's never like the big thing. Probably JEP 401 Valhalla, which we get to later, is probably closest to that. But most of the other things are like, oh, well, great, now I can use the underscore. How big deal, big whoop. But it fits into something larger that people should use then,
But even like, JEP 401 and Valhalla is a good example, right? JEP 401 represents what is the smallest piece of Valhalla that we can ship, on its own. And so there's going to be some people who are like all excited, yay, Valhalla's finally shipping. And then there's going to be the naysayers out there, of which there are a few, who are going to say, oh, but they didn't do the null restriction. Oh, but they didn't do generic specialization. Oh, but they didn't do operator overloading. And that's true because we didn't want to wait until we did all of those things to ship anything, right? And so we're constantly trying to say to look at a JEP and say, is there some way that we can carve this up into a smaller piece that still has an organic wholeness to it?
Yeah. So on the topic of like different arcs within Amber, you said that there's like a little bit of random miscellaneous features like the text blocks and var that you mentioned. And then you mentioned 2 explicit stories, which is the on-ramp and pattern matching. And at least on pattern matching, my impression is that like the main arc is slowly coming to an end. Basically, we know pattern matching kind of does its thing, and now we'll slowly see where else we can use patterns. And we heard that there's deconstruction, which probably, maybe I'm giving myself the answer. I was going to ask, what's other big arcs coming?
Yeah.
And I'm wondering, is deconstruction already its own arc? Because I know there's a lot of work going in that, right?
Yeah, I think so. I think we're coming to the end of sort of the data-oriented programming arc, which is, record sealed types and simple pattern matching, type patterns and record patterns, et cetera. And, that's a really useful, thing unto itself. But there's kind of another arc coming that also leans on pattern matching, which is being able to create your own patterns. And basically any code you write that is conditional, where you look to see if some object is in some state, and if so, you extract something interesting from it. That is logically a pattern, but we've always had to write that in a way that made it not as obvious that it's a pattern. And so the next big arc is bringing patterns into the programming model itself, into the object model itself, where a constructor captures how I take an object's ingredients and turn them into an object, and then you have the reverse of that process of taking the object and breaking it down into not necessarily the exact ingredients that you were handed as a constructor, but ingredients that would be suitable for recreating this object. And the reason that's important is that there are a lot of mechanisms, both in the language and frameworks, for taking things apart and putting them back together. Serialization is an example of that. Withers is an example of that. Where you have an immutable object and it has 17 fields, and you want to keep 16 of them but change one of them. Well, you want to take it apart, make one small little change, and say, now put it back together. And in order to make things like that not horrible and messy and ad hoc, you have to have a mechanism for taking things apart that is sort of at the same level of abstraction and prominence as constructors are in the language model.
But that also means that this taking apart really, we're getting way ahead of this, right? I'm thinking about what would be a good way to use this feature, describe this feature, but you're really describing it as the inverse, basically, of the constructor, right? Yeah. So it's not, I probably shouldn't think this use case could be niftily expressed in a pattern. I'll just write a pattern that just returns something. You said it should at least resemble the constituent components of this instance. It should just be random content, or so. I'm wondering, what about we talked about this way back, I think, about a map and a key that contains. Yeah. So a map contains a key. Will I be able to write a pattern that says, well, if the key matches, here's the value? So I don't have to do the if map contains, then map get?
Yes. So map.get is a particularly problematic method, right?
Yeah.
So the way it was written, in Java 1.2 is that it's a method.
It's like you're pointing to the past, like it's those guys.
But we had the tools that we had at the time, there's this magic value null that is a universal sentinel, and we return that if we can't find it. And that's horrible, because what if your map contains null as a value, right? How do you tell the difference between there was no mapping present, or there was a mapping to null? And some map implementations don't support null as values, and some do. And you could ask contains key. But what if the map is a concurrent map, and some other thread might be putting values in it between the time you ask, does it contain the key, and okay, get me the key, right? So map.get was a significant compromise. Since then, the language has evolved quite a lot, and there are a number of other ways we could have chosen to write map.get. I'm not going to say one is better than the other, but it could have been something that returns an optional. Yeah. It could have been something that takes a lambda.
That specific example, if the map can still contain nulls, the optional is still kind of misleading, right? Because if the map can contain a null, you still have to return the empty option, and then the empty optional still doesn't tell you whether it was null or not.
Yeah, that's
true. Should have written an optional that can contain null. I shiver when I think about it. Yes,
and soon we'll have nullity control in the language, and so we'll have more tools, and at that point it becomes reasonable to say, well, would we have written it differently? We can't go back and change the past, right? Yeah. But would we have written differently? And patterns are another tool that we have to express conditionality in APIs.
Okay, but then I wonder, should a deconstruction pattern should deconstruct? Again, the map probably somehow, maybe a map just shouldn't have a deconstruction pattern. But if it would, it should deconstruct into all the keys and all the values, right? Because you said deconstruction should really reflect the whole state of the thing, and not just a little slice of it.
Yeah. So deconstruction patterns, not to get too far ahead of ourselves, but deconstruction patterns are
Too late, I think.
You can think of them as the inverse of constructor. Well,
Yeah.
we have other named blobs of code in classes. We have static methods and instance methods, and they might reasonably have an inverse as well.
Okay.
So we have map.put, which is a way to put an element, into a map, talking about one element. So you could imagine a pattern, not a deconstruction pattern, but an instance pattern that would express, a conditional query about the map that might be able to focus on a single element as opposed to the whole map at a time.
Okay, so that's what Amber is going next. On-ramp is still going on, and then also, now that the main pattern matching arc is done, it's about custom patterns deconstruction, or rather the other way around, right? First deconstruction, then custom patterns. Okay, is there anything else that you can do? I know you have like these heap of notebooks. Surely there's something in there that you're also thinking about. But if you can't share it, I understand. But is there something?
Well, so there's a sort of wave of stuff that's coming from Valhalla that's going to affect sort of every corner of the language, which is null restriction.
Okay.
Right. So null restriction, is a feature that some programmers are familiar with from other languages like C# or Scala or Kotlin, where you're able to say this variable contains a string but not null. This variable contains a string and deliberately includes null. It's not an accident if it's null. And that's a way to be more explicit about the value set of a variable, and that's useful, and that's something that people have been asking for a long time. It also turns out to be something that is essential for Valhalla, both from a performance perspective of being able to give flatter and denser memory layouts, but also because of initialization, and we need a way to talk about to be able to talk about this variable can't be null, and it's provably initialized before anybody can observe it. And so that provided sort of the final impetus to address the nullity problem, which is challenging and has some surprising consequences, but that's going to ripple through everything else, right? It's going to ripple into pattern matching, for example, because if you have a type pattern string S, well, if you're able to denote the type non-nullable string, then you have to define the semantics for what is a non-nullable type pattern or explicitly nullable type pattern, and so there's a whole wave of threading these things through pattern matching, bounds conformance, type inference, all of these, overload selection, all these different corners of the language. And I suspect that that's going to consume our JLS update bandwidth for a while. Okay.
So that also means, in the spirit of things coming somewhat in slices, and so that people who observe, they shouldn't get ahead of themselves and see one slice and say, oh, well, that's not all I wanted. Does that also mean that even if we get null-restricted types, that they might not immediately work everywhere, but that there might be a phase where, we get the feature now and it works like in 80% of the places, but patterns, for example, need to be updated in the coming releases?
So that's a hard one, because we on the one hand, we'd like to sort of carve things up into sort of minimal deliverables. We also want them to be clean. The kind of the rubric that we apply about could this be a standalone JEP is, if this were the last JEP ever, would we leave the language in a clean state?
So the answer then would be really no for what I just proposed.
Right, because that would be leaving something in a half-done state. And so that's probably going to be a fairly large JEP. Even if its syntactic intrusion into the language is small, its intrusion into the spec will have something in each of the 18 chapters of the JLS.
Okay, that sounds like fun.
Yeah. Well, yes. That's what we do.
Okay, we got about 1 more minute left. You just briefly mentioned Valhalla, and in that talk yesterday, you also, towards the end, gave a little bit of a roadmap, which I should say doesn't contain any timeline, doesn't have any dates. But I still found it interesting that you now have a better, or you're sharing now a better picture of what order are things going to happen. Because there were a couple of JEPs flying around. There's JEP 401, which is just value types, and then what did 402 do again?
Well, so the funny thing is 402 isn't the next one after 401.
Exactly, that's
we thought it was at the time we wrote it.
Exactly.
And then over time our perspective evolved, and that's actually kind of like fourth in the current lineup. So the two in between have to do with null-restricted types purely from a language perspective, and then with the interaction between null-restricted types and value types, which enables greater flattening, of object graphs.
Okay, so the current thought process is JEP 401 will introduce value types.
Yep.
then this unnamed JEP will introduce null-restricted types.
Right.
Funny that Valhalla took on another big project, by the way.
Yeah.
And then the next unnamed one will not have any language exposure, but just change how these interact.
You can think of it as like a multiple inheritance thing, where like you have value types is independent, null restriction is independent, and then they sort of have a child, which is null restricted value types.
Yeah, but those are so we're saying that's just like that's more like on the JVM side, so it flattens and denses more. Okay, then after that we get maybe JEP 402.
JEP 402 is kind of a loose end cleanup where it has to do with taking the primitive type int and the null restricted value type integer bang and minimizing the gaps between those two types, because morally they should be the same type.
Yeah.
Right. But and we can make 98% of them overlap, but there are some loose ends of currently we treat int and integer different in overload selection, for example, and we're not going to be able to change that. But but what we can do is align things like can I treat an array of int like an array of integer bang and vice versa?
Yeah.
And can I get array covariance between int array and object array?
Yeah. That's all very exciting. I'm gonna somehow stop myself, and I want to get like praise for the self-control to not ask you when though, because I want to know. But okay. Thank you very much for that insight.
Yeah.
I'm looking forward to seeing all that stuff. So I hope you go back and work on it right now.
Absolutely.
Thank you, Brian.
Thanks a lot.